Hey guys, it's Mr. Hing here. I hope you're all well and doing okay and not so stressed regarding your end of year exams. Today, what I'm going to be doing, guys, I'm going to be doing paper one preparation or revision, right? And the topics that I'm going to be touching on is HCF and LCM, factorizing integers, exponents, graphs, and algebra with regards to expressions and equations. Now, I don't know how much I'm going to cover in this video, but I'm going to try and cover all of at least these three topics. Depending on how long I take, I'll just break them up into individual videos. Okay, so without any more speaking, let's get straight into it, guys. So we're going to be dealing first with highest common factor and lowest common multiple, which we all know is such a common question that they may ask, right? So let's go and see how we do it. So I want to really try and see if we can do it in such a way that we never get it wrong, okay? So the first question is, what is the highest common factor between 68 and 72? Now, guys, when they ask this question, please go ahead and do yourself a favor and list the two numbers as the product of its prime factors. Remember, what is a prime factor? Well, it is a number. Let's deal with 68 for instance. It's a number that can go into 68 without a remainder, right? But it's a number that can only be divided by itself and 1. Okay, that is a prime factor. So when we list the product of the prime factors for any number, guys, when we use the ladder method, we need to always start with the lowest prime factor of that number. Okay, so let's go ahead and see what we get. So the prime factors of 68. So we start off over here, 68, and then we know that the lowest prime factor, remember we don't use 1, the lowest prime factor is 2 over here, right? So then 68 divided by 2 is 34. What is the lowest prime factor? It's 2 again, so 34 divided by 2 is 17. And what is the lowest prime factor that goes into 17? It is only 17, okay? 3, 5, 7, they don't go into 17. So the next prime factor will be 17, and 17 divided by 17 is 1. So these over here, guys, on the left-hand side, these are the prime factors of 68, right? So then you go ahead and you write 68 equals, this is how to write as the product of its prime factors. So 2 to the power of 2. Why to the power of 2? Because there are two 2's. There's one over here and one over here. So it's 2 to the power of 2 and then times by the 17, and that has an imaginary 1 at the top over here. Okay, so that's the product of the prime factors of 68. Let's move on to 72. So 72, again, we start with the lowest. So 2 can go into 72. So 72 divided by 2 is 36. 36 can be divided by 2. So 36 divided by 2 is 18. And then 18 also can be divided by 2. So we get 9. Now, 2 doesn't go into 9, right? So now we need to think of the next smallest or lowest prime factor, so that is 3, and 9 divided by 3 is 3, so 3 divided by 3 is 1. So guys, here we go, always on the left hand side. When you do the ladder method, all the prime factors are here and we write it out as a product, meaning times. So 72 will be equal to, how many 2's are there? There's 3 2's, so it will be, the base will be 2 and the exponents will be 3 because there are 3 of them, times by 3 as your base again. And how many 3's are there? There are 2 3's there. So now, guys, we have done the difficult part. Now, the easy part is here. All we need to do is choose some things over here according to the rules. Now, please notice over here, guys, what I have written over here for us. The highest common factor, when we deal with that, please make sure you understand this, that with the highest common factor, how we determine what it is after we've done all of this hard work is we are going to choose only the common bases between the two numbers. So, Mr. Hing, what do you mean by that? Well, what I mean is, if we look at all the bases for 68, we have 2 and 17. The bases for 72, we have 2, and 3. So we're only going to choose the common bases, right? So what are the common bases here? Well, 2 is over here and 2 is over here. Those are common, right? So we're going to choose 2. And then don't choose any other bases because they're not common with each other, right? And then of that base, of the base that we have chosen, in this case it is 2, we choose the lowest power out of the 2. So what is the power over here? It is 3. And what's the power over here? It is 2. So we're going to choose that and put it above our base that we chose. And that is it, guys. That is how you choose the highest common factor. So it will be 2 to the power of 2. And that is equal to what? It is equal to 4. So this is how we do highest common factor. Can I do one more example with you? Okay, so let's have a look at between 200 and 150. So let's have a look here. Again, what did I say? You start off with listing your prime factors, right? And the product of it, which will be helpful. So let's go. So it's 200. What do? We divide by 2, the lowest prime factor possible. So it's 2. 200 divided by 2 is 100. And then 100 again is divisible by 2, so we get 50. 50 is divisible by 2, we get 25. And then 25 can't be divided by 2. And the next prime factor 3, well, it doesn't go into 25. So the next one, please remember you don't choose 4. 4 is not a prime fact or prime number. So the next prime factor is 5, and it does go into 25. So 25 divided by 5 is 5, and then obviously we'll choose 5 again. So 5 divided by 5 is 1. So how many 2's do we have? So we're going to have a base of 2. How many 2's do we have? We have 3 2's, and our base is 2. And then the base of 5 will have 2 at the top. Okay, so let's do 150. 150, again, it's divisible by 2, so we choose that. 75, it's divisible by 3, not 2, so we use that. Gives me 25. 25 divided by 5 is 5. 5 divided by 5 is 1. So then we write these out as the product of the prime factors for 150. So it will be 2. There's only one of 2, remember, times by 3, because there's a 3 here. So there's only one of them, and then times by 5. And there's 2 5's over here, so there will be a 2 over there. And then, guys, what are the 2 important parts? Common bases, the lowest power of them. So let's have a look. What are our common bases in this case over here? So we have a 2, a 5, a 2, 3, and a 5. So what's common? The 2 is common, so we're going to choose that. So we write down 2. Then the 5 is common, so we are going to write down 5. And then we're done with that. The next one is the lowest power of those. So the 2 over here has a 3. That's 3. And then 2 over here, it has an imaginary 1. So we're going to obviously choose the lowest, which is the imaginary 1. Then 5 has a power of 2, and 5 has a power of 2, so you can choose any one, and that will be the answer there. So then what we do is, guys, we put that together, we write them, and we times them together. So that after you make the correct decisions, you multiply them together. So 2 to the power of 1 is still 2, times by 5 squared is 25. So 25 times 2 is 50, and that is the highest common factor. Okay, guys, let's have a look at what happens when we are going to do LCM. So it's the exact same process. You can see it's very similar to ladder method and writing out the product of the prime factors, but then something very important is happening over here. Sorry, I didn't mean to scroll there. Something is very important over here, and that is that we need to choose one of every base this time. Every base, not just the common ones. And the bases that we choose, we need the highest power. Okay, not the lowest power, which is what happened in the HCF. So we do this again, do that well in the test. You get all your hard work out of the way, right? We do that. So again, just like prior, we get 2 to the power of 2 like that, times by 17, and 72 was written like this, okay? Now, let's do the important part where we score our marks as well. The last part. So the LCM, guys, we need to follow these 2 rules this time. So let's choose one of every base. So for 68, we have a base of 2, a base of 17. 72, we have a base of 2, a base of 3. So now we need to choose one of every base. So we're going to choose 2. We're going to choose 17, even though it's not common, we want 17. Then 2, you don't choose that again, right? 2 is already there. And then 3. 3 is not there, so we choose 3. And then we have completed that task. The next task, we choose the highest power. Okay, so for the base of 2, we have 2 as a power over here, but we have 3 as the power over here. So we're going to choose that one. So let's choose that one. And then 17, we only have this imaginary one, so we choose that. And then for the base of 3, we only have this base of 3, so we have to choose that too. And then, guys, you times them together, just like HCF, and we get our final answer of 1,224. Okay. All right, last one, and then we'll end the video there, and we'll move on to the next topic in another video that I should post today. All right, so we have 150. Right, we're doing LCM this time, guys. What are the two rules? We need every base, remember, and the highest power of those bases. Please remember that. So again, I did it just like I did it on this side over here. So we get the product of the prime factors for both, right? We get 2 to the 3 and times 5 to the 2, and then same over here, 2 times 3 times 5 to the 2. Then, guys, let's complete our two things that we need to do. So we need to choose every base, right? So we have 2, 5, 2, 3, and 5. So we're going to choose 2, definitely, 5, absolutely, and 3 over here. Don't forget the 3, right? So we have 2, 5, and 3. Then we need to choose the highest power of each base. So the power here is 3, power here is 1. So we're choosing the 3 over here. Well done. The 5 is the 2's over here, 2's over here. So we're going to choose the 2. And then the 3, we have to choose that one. So you put that in your calculator, guys, and you get your answer of 600. And that, guys, is how we do highest common factor and lowest common multiples of numbers. Thanks, guys. I'll see you in the next one. I'll be covering a different topic as shared in the video previously, or rather earlier. Thanks, guys.